दीजिए ना नेट। हाँ बताइए ना। आप हॉटस्पॉट ऑन करें।
एक मिनट हमारा देख लो नहीं तो बोलो।
देखिए इनका जो कनेक्ट है ना एकदम ठीक चल रहा है, इसमें आप कुछ भी चेंज मत कीजिए। इनका जो है इससे रहने दीजिए, बस इसमें अभी हम चेंज कर रहे हैं।
तुम लोग बैठ जाओ सब लोग, कभी तो होगा। राजीव तुम्हारे बाकी क्लास में कहाँ पे हैं?
आप इसको एक बार
क्या हुआ? ऑन करो ना, दिक्कत क्यों नहीं होगी? तुम्हारे लैपटॉप पर किसी और का उसमें दिक्कत थोड़ा देर यूज कर सकते हैं। उसमें अगर दिक्कत स्क्रीन देखो। आप नीचे करिए और जो नोट है ये कहा, वो तो है ही नहीं जिससे जुड़ा हुआ है। प्रगति प्रगति के मोबाइल से कनेक्टेड है, प्रगति आ रही है यहाँ पे, यहीं पे है। फिर क्यों नहीं हो रहा? अब दिखो ना।
वाईफाई लिखा हुआ है ना। नहीं रहने दीजिए सर, इनके अगर जरूरत पड़ा तो हाँ कोई अभी अभी इधर ही हाँ हम भी इधर ही छोड़ दिया अपने घर।
सामने क्या हुआ दिख रहा है?
ठीक है
इससे मूव हो ही रहा है।
देखिए एकदम सही है अभी, अभी तो सब कुछ ठीक है।
शाम्भवी अभी बिल्कुल सही चल रहा है सब कुछ। शाम्भवी इसी से चल रहा है, इसी से कर दो। बुला लें सर को, बुला लें। दिनेश सर कहाँ है आपके? हाँ
हाँ आप माइक लगा लीजिए पेन से लेके। मिराज माइक दे दीजिए, माइक को आप कहीं पे होल्ड कर दीजिएगा। ये वाले को भी आप माइक इसको कहीं पे पॉकेट में या कहीं पे भी इसको इन कर दीजिए। इसको लाइन पे तो आप अगर चिपकते हैं इस तरह से, चिपकते यहाँ हाँ ठीक है बहुत अच्छा हो गया।
second. Point off.
इसको आप लगाए रहिए, इसको ऑफ कर दीजिएगा बोलना। नहीं तो लाइट वाइट इसमें नहीं है।
तो फिर
मेरा कैमरा वाले को घुमाना पड़ेगा, दिक्कत नहीं है।
Good morning, ma'am.
Good morning, sir. Good morning.
First of all, I would like to tell you that I, my Professor Ram Bali Singh, HOD of Geology Department, Patna University, on behalf of me, I would like to request you to start the open Viva-Voce examination of Miss Miss Shambhavi. Shambhavi, and her topic is a study of depositional environment and tectonic setup of Rohtas limestone of Shemri group along Son River in Rohtas district, Bihar. Ma'am, I would like to request you to start the examination of open examination of Viva Voce and ask two questions relating the Shambhavi, please.
Okay. Okay.
Oh.
So, good morning, everyone, distinguished members of the doctoral committee and head of the department, research supervisor, and the dean, the faculty members. And it is my privilege to be a part of this Viva-Voce examination as an external examiner. So, after her presentations, and uh, would you like to like me to summarize her thesis, or straight away we can call her for the?
Whatever you like.
Okay, so first I would like to summarize her work, and then we can call her for the examination, for the presentation.
Okay.
So, and I just would like to summarize her work. And the Shambhavi, she worked on the study of depositional environment and tectonic settings of Rohtas limestone of Semri group along the Son River and Rohtas district, Bihar. And so the candidate had demonstrated in addressing the depositional environment and tectonic framework of the Rohtas limestone within the Vindhyan basins, one of the most significant Proterozoic basins. And the aim and objectives are very well defined, and the literature review reflects the deep understanding of sedimentary geology and depositional system. And the candidate employed the diverse approach methodologies like field mapping, petrography, geochemical analysis, XRF, QICPS, and all that, and then isotope stable isotope studies. And this multi approach strengthen the reliability of the interpretations. And um, And when you see, while the interpretations are very sound and more detailed comparisons with other proterozoic basins of India could have been further strengthened the regional and significance of the findings. And the overall we can say that the thesis reflects the originality and depth of analysis and high level of competence in sedimentology, geochemistry, and tectonics. And Ms. Sambhavi has made a meaningful contribution to the understanding of proterozoic depositional environment in India. With this background, I invite Sambhavi for presenting to defend her PhD thesis.
Sir, please you start.
Respected teachers and my dear colleagues, my name is Shambhavi and I am here to present my thesis on my research topic, study of depositional environment and tectonic setup of Rohtas limestone of Semri group along Son river in Rohtas district, Bihar. These are the contents. These are the contents of my thesis. Introduction, literature review, methodology, field investigation. I have tried deep analysis of geochemical analysis on my area. First of all, what are proterozoic basins? These are mostly flat-lying, unmetamorphosed, and partly deformed tectonic basins forming an integral part of the Precambrian shield of India. They were first named by T.H. Holland as Purana basins, and they are mostly developed at the periphery of Archean cratons. They cover approximately 20% of land area in our country, and they are mainly fluvial to shallow marine sequences. These are the major proterozoic basins of our country. Now, my research work comprises a study of Vindhyan Basin. So, these are the largest Purana basin in the Indian Peninsular Shield and the world's second largest Purana basin, named after the Vindhyachal mountains, ranging from Mesoproterozoic to Neoproterozoic in age. And these are surrounded by the Son Narmada faults and in the south and Great Boundary Fault in the northwest. These extend from Sasaram in Bihar to east of Dholpur in Rajasthan, passing through the Son Valley, Bhopal Dhar forest, Chittorgarh and Savai Madhopur areas. Now geologists have divided Vindhyan strata into three sectors: the Son Valley, the Bundelkhand and Rajasthan sector. This is the Vindhyan supergroup map of India, covering the central part of our country. Now, in Bihar, the rocks of the Vindhyan supergroup are spread over an area of 3,350 kilometers square in districts of Kaimur and Rohtas region. The Kaimur district comprises the entire Kaimur group of Upper Vindhyan group, and the Rohtas district comprises both the Semri and Kaimur groups. 7 formations of Semri group are recognized, namely the Rohinian sandstone, Gajrahat limestone, porcelainite formation, Khenjua shell, Pond limestone, glauconitic sandstone and Rohtas limestone, of which the first 4 are discovered in Jharkhand, and the upper 3 have outcrops exposed in Rohtas district. This is the geological map of Vindhyan Basin of Bihar, and this is my study area. This is the geological map of Rohtas district. This is the stratigraphic succession of Rohtas district. My research work included study of stratigraphic framework of Rohtas limestone and overlying Ghaggar sandstone of Kaimur group, their sedimentary structures and textures, and their significance in determining the environment of carbonate deposition, their petrography, and their geochemical analysis, along with stable isotope ratio analysis of carbon and oxygen. I have these are some of the major contributions towards Vindhyan supergroup was first started by T. Oldham in 1856, then by H.B. Medlicott, then an extensive the major work which we still study and refer to was done by J.B. Auden in 1933. He surveyed the area around present day Mirzapur district in present day Uttar Pradesh and Bihar. The 50s and 60s decades where geologists mainly focused on sedimentation and environment depositional environment analysis of the area. The systematic mapping of Rohtas district was first started by GSI in year 1974-75 by Om Prakash, Y. Kumar and Singh on topo sheets number 63 P by 13 and P by 14, which covers my study area. Then the later decades focused on stratigraphic study, their petrographic study, their depositional environment, tectonic setup, geochemistry, and the paleontology. My thesis comprises of the following. I have covered following work in my thesis. These included field work with collection of samples, their preparation, their petrographic analysis, ICP-MS analysis, XRF analysis, stable isotope ratios, EPMA and SEM analysis. Field and I surveyed my field area 4 times, first in June 2021, April 23, February, and in February and March 2025 at multiple locations in Rohtas district such as Nohata, Ramdhira, Amjhor, etc. And along these I have studied structural and textural features for stratigraphy, deposition, tectonics and provenance. The first site included Nohata. This site we discovered Rohtas limestone, and the upper layer of Rohtas limestone along with Ghaggar sandstone. The contact in this area was found to be unconformable with a 50 centimeter layer of pebbly PBC lying in between the two strata. Tectonic disturbances in the form of bodinages, two sets of joints and silicified layers and folding were present in the area. In this photograph we can see that there is alternate layer of light and dark layers of limestone. The lighter layers comprises of silica, and through this we can say that there was cyclic sedimentation of the strata. In Bawalia we found extensive tectonism features such as box folds, antiformal structures, chevron folds, and microbial mats and fault breccia along with bodinages were found in this area. These Ramdhira is a site of abandoned limestone mines. Here also we found some of the chevron folds and weathering, and the limestones were found to be in yellowish in color, depicting oxidation of the area. In continuation with Ramdhira, there is Tutla Bhavani Mandir, where we found 3 sets of beddings in the Ghaggar formation, and current bedding features such as ripples and ripples and lenticular bedding were found in this area. At the back side of Tara Chandi Mandir, we found massive Rohtas limestones, in which here we found a reverse fault in this area, where the base comprised of the Ghaggar sandstone, and the base comprised of Ghaggar sandstone, and the hills comprised of the Rohtas limestone. In Dhodnar area, we found the Dhandrol formation, the uppermost formation of Camur sandstone. In Bajipur section, we found asymmetrical remarks, striations, crossbeddings, and folded strata of Rohtas limestone. Here, these are also part of abandoned mines, and as a result of mining, groundwater has appeared on the surface. Here we found, in Baduhi, we found the silicification and folding in limestone beds, and silicification and folding in limestone beds. Mulli Pahadi is a site which is currently leased to Kalyanpur Cements. Here also we found asymmetrical folding and groundwater on surface as a result of mining. Amjhar section comprises of Rohtas limestone plus the entire Camur group succession. Here also we found PBC in the area. The contact was found to be unconfirmable and nodular. And here the middle section of Rohtas formation, the nodular limestones were found along with overturned folds and recumbent folds. In Chunhatta, we found the uppermost section of Rohtas limestone, and sedimentary features like wave ripples were found in the area. Sijhua Hills and Durgavati Dam were the places where we found Ghaggar sandstone, and features such as trough crossbreeding and folding in strata were found. Now I have collected total 64 samples in the field area, of which 42 samples were selected for thin section analysis, of which 28 were from Rohtas limestone, 13 of Ghaggar sandstone or lower Camur sandstone, and 1 of Dhandrol quartzite. For limestones, Folk's classification were used, and on the basis of classification, in his basis includes as classification as either micrites or spherites, with qualifiers added for the kinds of allocamps. For Ghaggar sandstone, Folk's classification was used for finding relative abundance of quartz, feldspars, and rock fragments. This is the QFL percentage of each of the 13 sandstones I have collected, and this is the QFL classification ternary diagram by Folk of my samples. Here we can see the samples are mostly concentrated on the quartz pole of the diagram, so they were found to be arenatic sandstones. In Nohata, 7 samples were collected, of which 4 were from Rohtas formation and 3 of Ghaggar formation. The limestones were very fine grade, argillaceous, and exhibit typical micritic texture, very poorly sorted and texturally immature. They show high birefringence order and were strongly pleochroic, and flakes of muscovite and inclusion of clay minerals were observed. In the Ghaggar sandstone, they were coarse-grained, arenatic, well sorted, and texturally mature. Mostly monocrystalline quartz were present, and the quartz grains exhibit features indicating stress in the area. So this is the clay mineral inclusion of Rohtas limestone along with micritic matrix, and this is the clay mineral inclusion of the Ghaggar sandstones. In Chunhatta, wavy laminations and muscovite and shale pairings were observed in the limestone along with micritic sphaeritic texture. Same in Akbarpur, very fine grained limestones and micritic texture of limestone and shale partings were found. Glauconite mineral were found in Baduhi area and along with entrapped gas bubbles. Mulli Pahadi area had more carbonaceous matter observed along with calcite veins which had secondary mineral replacement. In Amjhar section, fine grained crystals of fluorite were observed along with calcite veins, and the texture of limestones and sandstones were found as previous. Here we found extensive fractures in Ghaggar sandstone representing secondary porosity and tectonic stress in the area. Here also in Ramdira we found calcite veins along with carbonaceous matter in limestone. Again in Tutla Bhavani Mandir sandstone samples we found distress fractures in the quartz grains. Same in Sijwa and Dhodnar samples. Now on the basis of petrological studies, we tried to determine the source rock weathering conditions in the limestones. In the limestones, dominance of micrite along with siliciclastic input at a number of places suggests source rocks at nearby places with limited terrigenous and continental weathering. Under microscopes, micrites were found to be very fine grained, so their individual grains were difficult to distinguish, and features like microstylolytic structures, calcite veins and bird-sized structure were also common in the studied area. In Ghaggar sandstones, less quantity of feldspar and rock fragments were formed, and because of alteration and dissolution also indicate that the source area of sandstone has undergone a high degree of chemical weathering in a warm and humid tropical climate. For diagenetic modification of the area, the Ghaggar sandstones indicate towards compaction and precipitation of the siliceous cement. These processes signify reduced intergranular porosity and enhanced textural maturity. The feldspar grains locally underwent dissolution and alteration process and produced clay minerals which contribute to their secondary porosity. For Rohtas formation, the marginal marine conditions were traced because of micritic matrix, and with time mechanical compaction and pressure solution led to widespread development of stalolites and nodular limestones. The recrystallization of micrites and spherites led to reduced primary porosity, while chemically mobilized calcite precipitated as cement within intergranular spaces. For geochemical results, geochemical analysis, I have conducted XRF, ICP-MS, IRMS, and EPMA and SEM analysis. XRF analysis were carried out for 18 samples, of which 10 were from Rohtas formation and 8 of Ghaggar formation, for tracing major oxides like sodium oxide, magnesium oxide, etc. These are the results for major oxide concentration of Ghaggar sandstone. From this data, we have interpreted that the silica percentage in the Ghaggar sandstone ranges at a high level of 78.12 to 88.05%. In Ghaggar sandstones, calcium oxide is present in negligible value, and presence of alumina also indicates towards silicification of the sandstones. This is the major oxide weight percentage of Ghaggar sandstones. This is the major oxide concentration for Rohtas formation. Here we observed in calcium oxide is more dominant in magnesium oxides. Presence of silica in relatively high amount and ferruginous, along with ferruginous and aluminum impurities. This accounts for the start of silicification process at the end of SIMRI. The most limestone samples have calcium oxide content more than 34%, which is required for cement grade limestone with magnesium oxide content up to 12 to 16% as per Indian Bureau of Mines. This is the major oxide weight percentage for Rohtas limestone graph, and these are some of the bivariate plots for various oxides for Rohtas formation. For ICP-MS analysis, 35 samples of Rohtas formation and 8 of Ghaggar sandstones were analyzed at IUAC New Delhi, and through this geochemistry of trace elements and REDs were configured. This is the trace elemental concentration for Ghaggar sandstone and for Rohtas formation. This is the Conrite normalized trace elemental graph of Ghaggar sandstone and Rohtas formation. And this chart is for RED concentration for Ghaggar sandstone and for Rohtas limestones. From these all data, we interpreted that most of the samples show similar RED concentration pattern with relatively high value of lighter REDs as compared to the heavy REDs. There is overall a sharp increase in nodium values from PR and a very steep decline in samarium values in the limestones, whereas the pattern is not followed in the sandstones. The almost similar patterns of both the formations depict similar source areas of both formations, and at the same time there were some variations which predict that some amount of sediments were probably sourced from different areas. The RED signatures strongly indicate a dominant felsic upper crustal source for both formations, with differences between them reflecting variable contributions, mineral hosts and transport processes. This is the Conrite normalized RED graph for Ghaggar sandstone and Rohtas formation. And now Pearson correlation coefficient is used to compare two sets of data, normally ranging from -1 and 1. It measures the strength and direction of the relation between two variables. This is the Pearson correlation coefficient chart for major oxides for both the formations. For trace elements and for rare earth elements. From this the three charts we interpreted that for Ghaggar sandstones, calcium oxide has negative correlation only with silica and manganese oxide, while silica has negative relation with all the major oxides. Alumina has negative correlation with phosphorus pentoxide, and while ferric oxide has negative correlation with silica, while having positive correlation with other major oxides. For Rohtas formation, calcium oxide has positive relation with manganese oxide, and with rest it is negative. Aluminum oxide has negative correlation with magnesium oxide and calcium oxide, while ferric oxide has negative correlation with manganese and magnesium oxide. Trace elements show only a few negative correlation with each other, and for REDs, none have a negative correlation. For IRMS analysis, the 10 samples of Rohtas limestone were selected for carbon 13 and oxygen 18 isotopes. one sample of sample number AL2 were analyzed twice. It was a nodular limestone sample, one for its calcite part and another for its nodule part. This is the data for stable isotope ratio for Rohtas limestone. For EPMA, 6 samples of Rohtas limestone were selected. This analysis was done to trace out the micritic composition of the samples, because they were individually unable to we were unable to trace out individual elements in the fine-grained micritic limestone in thin section. First sample is C4, sample number C4. It is from Chunhatta area. This is a backscattered image. It revealed a homogeneous micritic matrix with a diffuse pressure solution, which seemed indicative of burial diagenesis. This is silica part, and this is its calcium oxide part. This is the analysis was carried out at 2 points, and magnesium, aluminum, silicon, potassium, calcium, and iron were found in the following mass percentage at both the formations. This is a Murli Pahadi area sample, and again the process of testing was similar. And here we at second position, at position 2, we found oxygen level, ranging from 42.23 at mass percentage in the entire matrix. This is a Amjhar area sample, and here we at position we found calcium to be at 100%, and at position 2 we found calcium to be at 98.12%. This is from Ramdhira area sample, and these are its chemical composition. This is another Amjhar area limestone sample, for which for only its nodular part, and iodine and platinum were found to be because of the configuration of the machine used. This is for the limestone. This sample is the limestone of the same sample, and these are its mass percentage. For same analysis, again the same 6 samples of EPMA were used. Now a detailed result analysis. For major oxides, a positive correlation between iron and silicon oxide in Rohtas formation indicates that most of the silica and iron present in the limestone occur as free silica and ferric oxide, oxide and hydroxide in cement and matrix. The silicon in studied limestone doesn't come from aluminous silicates, but instead occur as free silicon, and the iron not as ferromanganese. A strong positive correlation between silicon, aluminum, and potassium oxides indicates heterogeneous species of the limestones were mainly formed because of quartz, clay minerals, and potash feldspar, and is present as a fraction in studied carbonates. Calcium is of marine origin and is not influenced by a detrital source. These are the bivariate plots of Ghaggar sandstone of some of the major oxides, and for Rohtas limestone. This is the tectonic setting discrimination diagram for Ghaggar sandstones. This suggests that the unit was mainly deposited at a passive margin site. For trace elements, a lack of significant positive correlation of strontium with calcium and sodium is an indication that calcium and sodium oxide are not controlled by the carbonate phases. The strong correlation between trace elements is mainly depends on the heterogeneous input. However, contribution of diagenetic fluids play a significant role as trace elements were remobilized from both the carbonate and non-carbonate fractions and is present as an inclusion into cements and biogenic elements. Elements like barium, copper, nickel, zinc and phosphorus are commonly associated with primary productivity and burial of organic matter. An increase in concentration of aluminum, silicon, iron, manganese and barium is a result of both seaward transportation and downcutting of sediments. An increase in concentration of strontium and barium in limestone is as compared to other trace elements indicates substitution of these elements for calcium because of their similar charge and radius. For Rohtas formation, sodium oxide is found to be at 0.01%, indicating normal marine salinity and that sodium does not readily enter carbonate minerals. This much concentration is typical for open marine carbonate platforms where carbonate precipitation is dominant and detrital feldspar input is minimal. This also suggests clean marine carbonates away from major siliciclastic influx and deposition during quite quiescent tectonic conditions. For Ghagas sandstones, the value of sodium oxide was is a bit high, 0.04 to 0.08%, implying physioclase was almost completely destroyed before deposition, pointing towards chemical weathering under humid climatic conditions as predicted in from thin section analysis. It also indicates long transport, reworking and recycling of quartz grains in the Ghagar sandstones and combining with the high CI chemical alteration values, it indicates advanced weathering and recycled cratonic or passive margin source. Now zirconium concentration is used for tracing out how much detrital influence is present in a particular unit. So these are this is a positive correlation diagram of zirconium along with aluminum oxide and for Ghagar sandstones and Rohtas formation, and a similar type of chart was derived when zirconium concentration was compared with titanium oxide in both the formations. For REDs, a positive correlation amongst individual rare earth elements in the Rohtas formation reflects the incorporation within common detrital host phases derived from a stable felsic continental source and detrital control on RED distribution and negligible diagenetic or seawater modifications. In Ghagar sandstone, this positive correlation reflects the residence in common detrital host phases derived from a homogeneous recycled continental provenance. The coherent behavior of RED indicates intense source area weathering, high sediment maturity and negligible diagenetic modifications in the sandstones. This is the chart for Ghagar sandstones, which includes various ratios for REDs, including total RED, sum of LREDs, HREDs, their ratio, lanthanum upon lutate, and important indicators such as europium and cerium anomaly. And the same data for Rohtas formation. Now the interpretation, the Rohtas limestone is marked by low total rare earth element, steep chondrite normalized LRED to HRED slopes and consistent europium anomalies ranging from 0.86 to 1.54. The Bundelkhand craton and adjacent proterozoic terrains, which consist largely of granitoids, TTG gneisses and older felsic volcanics are logical contributors given their proximity and known geochemical character. For Ghagar sandstones, little higher total rare earth element concentration, a flatter chondrite normalized profiles, and European anomalies also suggest a felsic provenance, including subordinate mafic or juvenile components and a larger contribution of detrital accessory phases. Taken together, the provenance evidence supports a model in which the Sembri carbonates were fed by dominantly felsic weathered continental crust with limited detrital supply, while the overlying Camus siliclastics record increased sediment influx from a wider catchment that incorporated both felsic, pratonic, and younger, less walled sources. The European anomaly is slightly higher than 1 for both the formations for most samples, and this corresponds to their respective LRER upon HRER values. This accounts for a slightly positive anomaly in their mean values around 1, indicating negligible anomaly as a whole. The high values of LRER upon HRER ratio correspond to their respective European anomalies. This may imply predominance of felsic igneous rocks in the source area. Similar correlation of RER suggests deposition in shallow sea levels, and the cerium anomaly were also slightly greater than 1 for major number of samples in both formations. This may indicate redistribution of rare earth elements during weathering and as a consequence of their fractionation. Since cerium anomaly was found to be approximately 1, they indicate no positive or negative anomaly, and this implies that deposition occurred under generally oxic surface water conditions with limited redox stratification. This observation is also consistent with sedimentological indicators for the Rohtas limestone as worked by previous geologists, who stated that Rohtas limestones were deposited in a shallow, low energy carbonate platform, and for the Ghaggar sandstone they have interpreted high energy nearshore and fluvial deltaic settings. Now the fractionation indices of rare earth elements and along with European and cerium anomalies. The sharper LRER enrichment and stronger European depletion in carbonates combined with oxic cerium signatures supports a picture in which carbonate precipitation occurred in well oxygenated shallow marine waters with limited inputs of reducing agents. The carbonate environment would act to dilute detrital rare earth elements overall but preserve the inherited fractionation patterns of the detrital load. The sandstones deposited under high energy conditions received and retained a larger proportion of detrital heavy minerals and thus show total rare earth elements and flatter RER profiles while still reflecting the oxic depositional conditions. The ratio of various lighter and heavier RERs as normalized by UCC values indicates the ratio tends to be 1 in most number of samples despite the formation. Although some samples show enrichment of light rare earth elements, and while some are enriched in heavier ones, in general the HRER values are HRER concentration was marked by lower values relative to fractionation of LRERs. And overall there is an even distribution of fractionation indices barring few exceptions in samples. These are bivariate plots of European and cerium anomaly and some of the lighter and heavier RERs. These are fractionation ratios for some of the trace elements and RERs for both the formation. This is for Ghaggar sandstone and for Rohtas formation. Now discussion. Y upon HO ratio for Rohtas formation approximately from 18 to 36 indicates contamination of carbonates by the influence of terrigenous material. It shows a significant variation between the open ocean seawater and the open margin seawater. For Ghaggar sandstone, the values are slightly low. It indicates stronger detrital input from mafic and intermediate sources also. It implicates surveillance control rather than seawater signal. The generally high thorium upon scandium ratios indicate derivation of sediments was predominantly from a felsic upper continental crust, while low chromium upon thorium ratios suggest negligible and secondary mafic ultramafic contribution. High cobalt upon thorium ratios are interpreted as a result from secondary enrichment of cobalt through hydraulic sorting and diagenetic processes rather than the primary source rock composition. ER upon ND ratios reflects the fractionation of LRER upon HRER in modern and ancient marine systems. The high ratio of at 0.27 for limestone signifies that the seawater signature is retained by the marine carbonates, and addition of detrital material or diagenesis can reduce this value to less than 0.1 because of preferential concentration of ND relative to ER, as is observed in the values of studied limestones. For Ghaggar sandstones, this value is approximately 0.13, which indicates relative LRER enrichment and low sediment recycling and detrition from a mixed continental source with limited heavy mineral concentration. Now, on the basis of these data, we have tried to decipher weathering and source area conditions of the studied area. The high LRER upon HRER ratios and elevated fractionation ratios in the Rohtas limestone suggest that the source rocks supplying carbonate terrains underwent substantial chemical modification prior to transport. Negative European anomalies of some of the samples are consistent with the significant removal of piezo-clays derived europium during weathering, leaving clastic material enriched in lighter RERs relative to heavier RERs. The higher fractionation for depositional environment and paleoredox conditions, since cerium anomaly is close to 1, they indicate no positive or cerium anomaly. The proportionality of vanadium to nickel expressed as V upon V plus Ni is commonly used to find information on EH, pH and sulfide activity and depositional environment during deposition of sediments. It averages 0.64 for Rohtas formation and 1.04 for Ghaggar sandstones, indicating anoxic to strong disoxic bottom water conditions during availability in the depositional environment and detrital control. The average value of for thorium upon uranium increases from 1.88 for Rohtas formation to 3.6 for Ghaggar sandstones. It indicates anoxic marine sedimentation for the limestones and anoxic environment for Ghaggar sandstones. This is the trace elemental ratios for Ghaggar sandstones and Rohtas formation. Some of the trace elemental ratios. On the basis of these data, अभी तो बहुत है. For stable isotopes, the carbon isotopes range from -4.2 per thousand to 0.3 per thousand. The nodular limestone sample was found to be strongly depleted, and they were therefore interpreted to best preserve the original isotopic signature of the sea present at that point of time. For the oxygen isotopes values range from -10.5 per thousand to -5.2 per thousand. The depleted value suggests alteration in marine settings post deposition, possibly because of diagenesis, because of influx of sea water, which is lighter than sea water. Combining both the data, we traced out that they are not comparable. They are comparable with the primary ratios provided by some of the earlier workers. This is the graph for stable isotopes of Rohtas limestone. This is a overlay map of C4 sample for EPMA. This is the intensity profiles at position 1 for various samples. The peak values here are of calcium, and here it's of magnesium at both positions. So 10, 15, 20 और होगा. So बस ग्राफ ही है. So, this is elemental distribution map of one sample. So similarly, I have traced out for 5 other samples for EPMA analysis. For SEM, also the same 6 samples were analyzed, and through this we have traced out the micritic structure, which was unable to be traced in the thin section study. The material was found to be dominated by highly porous sponge to mesh-like microfabric characterized by interconnected, rounded, and irregular pores and cavities. They have found they were smooth to rough ragged margins, indicating early dissolution or degassing related void formation. They also some of the samples also show microbial mat structures, indicating
Yeah. Yes, sir. Now we can keep this open for discussion and question from the audience. Then finally I will ask the question.
One of you can ask a question related to topics who are participating, other faculty member or other than faculty member. You can ask because they are open PhD फाइला होती जाने से सभी लोग से आमंत्रित हैं तो पूछना चाहते हैं. अभी वो तुम्हारा प्रश्न पूछना चाहता है.
Thank you, sir.
फैंडिंग बताओ तो फैंडिंग कैसा है दो चार लाइन में फैंडिंग अपना बढ़िया
Finding. Main findings ये थी कि overall at the end of SEMRI and CAMUR group, although maximum जगह हमें conformable continuation मिलता है, जो कि हम lower और upper विंध्यंस को हम divide करते हैं, क्योंकि रोहतास लाइमस्टोन जो है वो upper closing of SEMRI group कहा जाता है. तो although there is conformable सीक्वेंस, लेकिन कहीं कहीं पे हमें 50 सेंटीमीटर का पीबीसी मिलता है. लेकिन एट द एंड ऑफ जो अपर एंड है, बेसिकली हम लोग रोहतास लाइमस्टोन को तीन लिथो यूनिट्स में डिवाइड करते हैं. जो सबसे ऊपर है उसमें हमें शेली सीक्वेंसेस और सिलिसिफिकेशन जो है हमें उसका प्रिडोमिनेंस देखने को मिलता है. जो सबसे नीचे वाला है वो प्योर लाइमस्टोन है, और जो बीच वाला है उसमें हमें नॉडुलर लाइमस्टोन्स मिलते हैं, जिसमें जो नोड्यूल्स है वो चर्ट और फेरोजिनस मैट्रिक्स वगैरह उसमें उसका कंपोजिशन था। जो सिलिसिफिकेशन है वो वो इन कंटिन्यूएशन विथ कैमूर ग्रुप है, जो कि पूरा का पूरा सैंडस्टोन और एरेनेटिक टेक्सचर से वो क्या कहते हैं एरेनेटिक टेक्सचर से बना हुआ है। और जो रोहतास फॉर्मेशन है,
Congratulations, Shambhavi,
Thank you,
for
sir.
such a tedious and hard-working PhD.
Thank you, sir.
I had few suggestions basically. When you're talking about clay minerals, what kind of clay minerals you got and what was their source? That's a question basically. And in Amjor district, you get around 40% of sulfur, and
Yes,
you
sir.
have samples from Amjor. So you should look in sulfur concentrations also, not just on calcium and magnesium.
Yes, sir.
Second, and thirdly is like when you're talking about the europium anomaly and cesium anomaly, you should also look at the redox conditions, because like when you are similarly finding glauconites, which is majorly found in low reducing conditions, low oxic conditions. So when you are getting anomalies positive, so it has a correlation with it. You should look into
Sir,
that.
it has
Thank you.
correlation, but basically pyrite was found in Bijapur shale formation. Uh, uh, that is an upper section from lower Camur और घगर sandstone. तो वो यूनिट मैंने कवर ही नहीं किया। मेरा सिर्फ रोहतास फॉर्मेशन और कैमूर सैंडस्टोन, मतलब लोअर कैमूर सैंडस्टोन या घगर सैंडस्टोन जिसको हम लोकली कहते हैं, उनकी स्टडी पे फोकस था। और जो उनके बीच में जो इन्वायरमेंटल ट्रांजिशन हो रहा था, क्योंकि हमें कन्फर्मेबल सीक्वेंसेस ही मोस्टली मिल रहे हैं जैसे मैंने कहा, तो मतलब मेरा ये सोचना था कि मतलब जब कन्फर्मेबल मिल रहे हैं तो जो डिपोजिशनल सेटिंग है, जो रोहतास लाइमस्टोन की ओपन मराइन शैलो सी सरफेस है, और कैमूर की हमने देखा कि वो फ्लूवेटाइल या डेल्टाइक है। तो इमीडिएट जो क्या कहते हैं जो चेंजेस हुए इन्वायरमेंट में, वो क्यों हुए और कैसे हुए और कितने हुए, तो मेरा बस यही फोकस था। तो इसीलिए मैंने वो अपर कैमूर सेक्शन मैंने कवर नहीं किया।
Shambhavi,
यस मैम।
I have one question for you.
यस मैम।
Here, in the audience.
ओके।
So you have tectonic setup
Yes,
in
ma'am.
your thesis topic.
Yes, ma'am.
So what is your conclusion about the tectonic setup for Rohtas limestone in
Ma'am,
this area?
it was an intracrustal basin. Intra it was an
You have done good work. So we all congratulate you.
Thank you, sir.
On behalf of Malakudi, I also congratulate on behalf of Malakudi. Okay.
Yes, sir. Thank you, sir.
Okay. How are you, ma'am?
Good, sir.
How are you?
I'm good, sir.
Chaliye.
I'm good, sir. How are you, sir?
Okay.
Thank you so much.
Okay. Congratulate Shambhavi.
Yeah. Okay, congratulations. Shambhavi,
Thank you, ma'am.
very good presentation.
Thank you, ma'am.
Yeah. So can I ask few questions?
Yes, ma'am.
Okay. So very simple questions, basic questions. What are the key sedimentary structures did you observe in the Rohtas formations, and how do they inform depositional environmental interpretation?
Ma'am, key sedimentary structures were mostly indicate towards a little tectonic disturbances like bodynages uh, uh, they represented open marine conditions for Rohtas formation. Mostly at some places we found cross bedding and current cross bedding structures. Mostly, otherwise it was otherwise we didn't find much sedimentary structures. We found more sedimentary structures like ripples and laminations in Ghagar sandstones than Rohtas formation.
And you have stromatolites, right?
Yes, ma'am.
How do these stromatolites contribute to the understanding of paleo environment of Rotas limestone?
Ma'am, they indicate towards anoxic sedimentation at that period of time, and I haven't diverged much into the paleobotanical part.
Okay, okay.
I've
Okay.
just
So how do
traced
you
that I just traced that stromatolites were present in these limestones.
Okay, okay. So how do these stable carbon and oxygen isotopes help distinguish the depositional settings from diagenetic overprinting?
Ma'am, the oxygen isotopes uh, the oxygen isotopes confirmed that there was an influx of meteoric or juvenile water. It was the deposition didn't take place in a deeper environment. The some of the carbon isotopes may have been altered because of the organic processes such as the presence of stromatolites going on. They must have altered some of the isotopic ratios in the area.
Okay. So in what way your study refined the tectonostratigraphic models of the Indian basin? In what way your study refined the tectonostratigraphic models of the Indian basin?
Ma'am, these indicate an deeper these indicate uh, sorry, ma'am.
Okay. Okay. Okay.
Madam, another
Shambhavi,
examiner,
thank you.
another examiner, Professor Pramod Kumar is also here, and I would like to request him to ask if you have some questions.
Okay. Okay. Thank you. Thank you
Pramod
for
ji?
your.
Okay. No.
I've already examined the thesis, so no more question. Thank you very much.
Okay. Thank you.
Thank you, ma'am. And many congratulations from my side. We have done a commendable job. Good work. Keep it up.
Yeah. On behalf of faculty members and other than faculty members, congratulate Shambhavi that for that her good presentation and research work. Ma'am, we can congratulate.
Yes.
Yes, thank you.
Yes. Congratulations, Dr. Shambhavi. And
Yes.
congratulations to Dinesh Kumar sir for a very good work. And once again, I congratulate the candidate Shambhavi, and also the Dinesh Kumar sir for
Thank you, ma'am. Thank you. And
good
welcome.
work. Thank you, sir. Thank you so much.
हेलो। सभी शिक्षकगणों से एक आग्रह है कि आप सभी से आग्रह है कि लाइब्रेरी के अंदर नाश्ते की व्यवस्था की गई है। आप सभी से पुनः आग्रह है कि आप सभी लाइब्रेरी की तरफ प्रस्थान करें। धन्यवाद।